My name is Sean Jones, and today I'm going to talk about summarizing Web Archive Corpora via social media storytelling by automatically selecting and visualizing exemplars. That's a lot of words. We'll get into what they mean. I also want to thank my co-authors, Michelle Weigel, Michael Nelson, and Martin Klein for their help, and mention that this work has been approved per release by Los Alamos National Laboratory under a ton of different reviews. Martin Klein no longer works for Los Alamos National Laboratory, and neither do I. He now works for Pacific Northwest National Laboratory, and I just recently got a position at Google. So this is work that was completed and published in 2023. In this particular paper, which is available in ACM Transactions on the web, go ahead and read that paper to find more exciting details. Okay, moving right along. Receiving a collection of digital files with little or no additional information is like receiving a mystery bag. What's in it? Do you know if the bag is valuable to you? What can I ignore from the bag? How do I describe the bag to someone else? How much stuff is in the bag? Thematic web archive collections created through crawling are like our mystery bag. And even Andy Jackson here, who worked for the British Library, says we don't even know what we've got, especially for messy collections like web archives. And web archive collections, they have this temporal aspect that's unlike other document collections. Each seed, which is what you ask to record or capture, has multiple captures, multiple mementos of that particular seed. And so that represents that seed over time, as we see with the computer science department at Old Dominion University in 1997, 1999, and also in 2009. So it changes. And thus, we don't just have one document, we have many versions of the same document over time, and they are very different from each other. So understanding themed archive collections, where there's a particular theme that somebody was using to create the collection, is very, very challenging. There's multiple collections about the same concept, like this example of many collections of human rights. It's difficult to easily expose aspects of the collection, like time or a particular page or something like that. The metadata for each collection is non-existent or inconsistently applied. As you see in the lower left, this is a collection with more than 130,000 seeds and many, many more mementos, but no description whatsoever. As we see in the upper right, as the number of seeds increases for a collection, the metadata count goes down. Probably because of the human labor necessary to add metadata to that much content. And as you see on the lower right, there are more collections each year. So there's more than 14,000 collections. This particular chart was done in 2020. So human review of these mementos for collection understanding is very expensive. So how do we shortcut it? How do we give someone the idea at a glance of what's in the collection? Our proposal is a visualization made of exemplar documents, and I'm kind of spoiling things here by just showing you exactly what we're talking about creating. On the left, we have an archivic collection of 23,000 documents. On the right, we have a multimedia story of 36 exemplar documents, documents that were chosen out of the collection to represent it. And we also have this multimedia, pictorial, and other information sent-like experience for someone to understand the collection. Welcome to the Dark and Stormy Archives project. The idea for this, the name for this project came from this particular beginning of a novel that was popularized by this Peanuts cartoon. You can visit our website at the URL shown on the lower right and find out far more about us and our journey and how we got here. Now, Yasmin Al-Nomaini did something similar to this in 2017, but it only worked for collections about short events. It only worked for archivic collections, and it was heavily dependent on a platform called Storify, which no longer exists. So she came up with this cool algorithm, and we'll revisit this later, but the point being is that we're building on top of her foundation. And we identified multiple steps for generating one of these stories. We select exemplars, we generate story metadata, generate document metadata, visualize the story, and distribute the story. And today we're just going to talk about selecting exemplars. The other work that's available at that website can fill in the rest of the blanks for you. And please go ahead and read the paper, the TWeb paper that this is all based on, if you want to get into the gory details. So, how do we select exemplars? Well, to select exemplars, we want to select a small number of pages from the collection to create a summary story. Just like archivic collections are a smaller collection of documents from the infinite number of pages on the web, our summary story is a much smaller number of documents that come from those collections. Breaking exemplar selection down into a series of primitives helps us create classes of exemplar selection algorithms to meet different use cases. And this is where we get into sample, cluster, score, filter, and order. Filtering off-topic mementos is just one step in an of algorithmic primitives for selecting exemplars. If you think about things in these 5 primitives, we can build all kinds of algorithms for producing exemplars. So in this particular case, we filter to exclude off-topic. We also filter to exclude near duplicates, and then we do a true random sample of the remainder. And that is a very simple way to produce a set of exemplars. If we allow ordering, it allows us to create more meaning from a list of mementos. So if we order everything in the particular collection by its memento date time, that is when it was captured, and we systematically sample every jth memento, then we can produce another type of story, another type of summary, in a very, very simple set of primitives here. Scoring gives us an idea of how well a document meets the information needs represented by some sort of function. So we can filter to include only mementos that contain a given pattern, and then we can score the results with some function like BM25. And then we can order by descending score. And what we've just described is a very simple search engine. So simple search engines are a subset of this overarching idea. Clustering, based on a feature, allows us to imbue subsets of mementos with meaning. And thus now we can complete Al-Nomani's algorithm, which we now call DSA1, where we exclude the off-topic content, then we exclude near duplicates, we include only English language documents, then we slice the collection. This is a form of clustering that Al-Nomani developed by memento date time, and then we apply dbScan with TF term frequency SIMHASH distance to topically cluster the collection, and then we score by a specific scoring algorithm that she developed that takes into account things like page category and damage and other things. And then we filter to only include the highest scoring from each cluster. And then we order by publication date. We reproduced most of her algorithm with the exception of the visualize part because we're only selecting exemplars right now. We also need to account for the growth of web archive collections over time. Al-Nomani did not account for this because this was a phenomena that we discovered in 2018, where we see that we can represent the curatorial involvement with the collection as a particular archivist is adding new seeds and then crawling with new mementos. The seeds are represented by the green line, the mementos are represented by the red line. And thus we get an idea of the collection's holdings in a temporal way and how they fluctuate and change. And as you see over on the right, if these particular curves are in a particular direction, we can tell various things about the collection. So DSA2 focuses on representing these growth curves and also scoring mementos by their surrogate metadata, because web pages have metadata built into them to help them produce nice cards on social media. And so we use that to produce a score. So the first 2 steps are very similar to Al-Nomani's, and then we use k-means clustering in the third step to cluster the collection by memento date time, thus taking into the account the collection growth. Then we apply a LDA topic modeling for topical clustering, and we score based off of the availability of metadata, and then we can include only the highest scoring from each cluster to get our exemplars, and we order by publication date. DSA3 is another algorithm that we can develop that focuses on mementos that best match the collection topic In this case, we take advantage of the dbScan algorithm's ability to identify outliers. And then we exclude them in step 4, and then we do our k-means clustering on memento date time. We k-means cluster with TF-IDF for topical clusters, and then we use BM25 with the top named entities for the collection as a query, and then we include only the highest scoring from each cluster and order by publication date. You'll see some repetition in here, but the meat of each of these algorithms is slightly different. DSA-4 focuses on finding the most novel mementos. We don't bother with trying to get rid of outliers because we kind of want the things that are more different in the collection. That's what this particular algorithm gives us. So we exclude our off-topics, we exclude our near duplicates, we do our k-means clustering memento date time, and also again with TF-IDF, and then we score based on the distance from the k-means centroid. And if you have more distant documents from the centroid, then they are more novel. Even though they're still in the cluster, they're still on topic, but they're different from their neighbors. And then we include only the highest scoring from each cluster, and then order by publication date. So search engines are the de facto method of exploring collections. This is what everyone would do if they were confronted with their mystery bag. They would try to run a search engine on it. But unfortunately, they don't know what to type to do the search. But let's go ahead and assume that they're the baseline and that someone knows how to search. Then we can ask the question of how retrievable are the exemplars produced by these DSA algorithms? How competitive are these DSA algorithms to a state-of-the-art search engine? So we loaded 8 different archivic collections into different instances of Solar Wayback, which is a search engine that is designed specifically for web archives. And then we also executed our 4 different DSA algorithms to produce exemplars from these collections. And we then generated queries with 4 different methods based on the content of these exemplars. So we used the doc2query T5 method to generate queries that were very similar to what a human would type. And then we also decided to create queries based off of top entities, which simulates a human that's just looking for a particular topic. We developed a lexical signature, which represented a human who was trying to find something but didn't exactly remember what it was they were looking for. And then finally, the title is for a human that remembers the title of the document that they want to find, which turns out to be one of the most reliable methods for finding things on the web, according to other research. So we went through and did this experiment, and we found that retrievability shows us that some exemplars are not found within the top 10 blue links of Solar Wayback, or even after hundreds of search results. The mean retrievability on this particular graph is not very high. And so we see that as we increase on the x-axis the number of results that we consider, the retrievability does go up because we're considering more documents, but we have to go through so many. And yes, that is a log scale, meaning that you end up in the middle at 100 documents that you've looked at, and then 1,000 by the far right. Using the titles from the documents also doesn't improve retrievability. We would think this would. It just doesn't go up very high. And using the top entity increases retrievability of mementos, but only after hundreds of results, and eventually 1,000 results. And then if we invert this and try to figure out what percentage of the exemplars have 0 retrievability, we find that the percentage is relatively high at the beginning of the collection, or the beginning of the number of results that are considered, but then should go to 0 by 1,000. But we see that for some algorithms, it never gets there. And so some documents surfaced by DSA algorithms have 0 retrievability in Solar Wayback. This sounds bad, but it's actually good for the DSA algorithms because there are certain documents that are very, very important that the search engine did not turn up. So applying the DSA algorithmic primitives help us surface mementos that are not found by a state-of-the-art search engine. On the far left, we see a document from Twitter that was missed by Solar Wayback in a collection about NASA's social media, but it was surfaced by the DSA-1 algorithm. In the middle, we have a document that was missed by Solar Wayback in a collection about the government of Delaware, but it is the governor's page, surfaced by DSA-3. And on the right, we have a document which is Virginia Tech Magazine, which is talking about the actual Virginia Tech shooting, surfaced by DSA-4, but missed by Solar Wayback when run against a collection about the Virginia Tech shooting. These are not empty pages. These are not pages that are off topic. These are actually important. And so it's another way to explore these collections in addition to the search engine. So what do we do with these exemplars? Well, we can visualize each exemplar, and we already know how. The social card, Facebook, Tumblr, and a ton of other sites, we see these all the time, have social cards. And we can extract titles for the cards from HTML or generate them with language models. We can generate descriptions in all kinds of ways, including language models. But on the far left, you see I'm pointing out that they're also striking images. And the images are really what makes these stories something that people like to consume. And I hate to leave you hanging, but we don't have enough time for me to go into the random forest model that we created in order to select those particular images. You'll have to go ahead and read the paper to find out. I provided another link here to help you. So selecting exemplars is an important part of generating and sharing stories that summarize collections. We came up with various workflows as well. Once you've selected the exemplars, you can run it through our other tools to produce these particular stories and then share them on platforms like GitHub Pages. And using this method, we can compare thematic collections, like these particular collections about different shootings that occurred in different places in the world. And also, don't just think about the what I've showed you so far in terms of examples. Stories can summarize collections in many different ways. Consider an archivist dashboard view, if you will, which gives statistics and growth curves and exemplars and a variety of other things as well. We adapted this work outside of Archive.it and later outside of Web Archive collections to see how far we could take it. We have worked with the National Library of Australia to produce stories summarizing various collections from Trove and Pandora. As you see on the left, we have this carousel that provides this view into this collection about tourism. And here you see the images, you see information from the individual mementos themselves and different documents, and of course links back to the original collection. On the right, we have this wonderful timeline view developed by Himarsha to go ahead and show us these particular concepts and pages over time. And so what we have are different ways of looking into the collection, but we're still selecting exemplars. That is what is so key. And more recently, we explored combining these methods with generative AI to summarize the collections of Los Alamos publications. And so here we have a different type of story. We have a rendering where the user can choose their type of exemplar mining that occurred. So you can choose things that were more on topic or more unique, as you see on the left. We also provide a macro summary that summarizes the collection using Mistral, which is an LLM from France. We have developed ways of mining keywords, also with Mistral. And then there were different types of summaries based on CoStar prompts for different audiences in the upper right. And we have a hero image that's generated by Stable Diffusion based on a prompt generated itself by Mistral based on the macro summary. And then under that, we have our exemplar cards generated in the ways that I talked about before. So we move Web Archive collections from metadata, seeds, and mementos, like our collection about COVID-19 and our collection about the Virginia Tech shooting, to stories about people. We see people, we see places, we see emotion. So selecting exemplars is the important first step. So I ask, what story will you build with Web Archives?